We've already done a little bit of factoring in class, but I'm still going to start with those simpler types where you're either factoring out what they have in common, the greatest common factor, or factoring something that is a quadratic where the a equals 1, our difference of squares. We'll look at those. But then stay tuned, even if you're good on these, because I am going to look at factoring when a is not 1, which usually students struggle with a little bit, and some factoring by grouping when you have 4 terms. So first, starting with our example 1, sometimes all you can do is factor out something that they have in common. And in fact, we want to do this first no matter what. So our first step here is to say that we can divide, there's my dog, hey Jack. We can divide them both by a 2 and an x. So I'm going to take that out. It's important anytime you're factoring that you don't get rid of what you're factoring out, but now it's out front to where if I did multiply this back through, I'm going to get what I started with. Make sure that you're dividing that first term by what you factored out. So dividing that by a 2x, I'm left with x. Dividing negative 4x by 2x, I'm left with a negative 2. When I'm factoring a trinomial where a is 1, this is where I'm thinking of those two numbers that multiply to be negative 21 and add to be negative 24. There is no harm, even at this point in your math career, to start going through factors of 21. If it's something that you get to use a calculator with, go for it. But saying we've got 1 times 21, 3 times 7, and then that's pretty much it. But we're making sure that the signs here, one of them is going to have to be negative and one positive to end up being a negative 21. And in order to be a negative 4, I know that with my 3 and 7, the 7 would have to be negative. Always a great idea on this to double check that those two numbers do add to be your middle term. So it does add to be a negative 4, and they do multiply to be a negative 21. Never hurts to check. Our third type is the difference of squares, where we're noticing first we're only going to have 2 terms. They're both going to be a perfect square, so noticing that the square root of x squared is x, the square root of 25 is 5. And in fact, there are some instances where the second thing is not a perfect square, so I'll show you that in a minute. But I'm just going to be taking the square root of my first term, the square root of my second term, and then one of them will be positive, one will be negative. I could also think of this as an x squared plus 0x minus 25, because if you are thinking of two numbers that add to or multiply to be a negative 25, and add to be 0, it will be negative 5 and 5. So if you have to think of it that way, that's fine. If this was not a perfect square, so if you had like an x squared minus 20, in most cases you're just going to leave it like this, because if you're solving you would just add the 20 over, but there are some cases where you want to go ahead and factor this, and in that case you are allowed to say that this would be x plus square root of 20, x minus square root of 20. Not a lot of instances where you want to see it this way, but it's not incorrect, because if you did multiply it back through, they do add to be 0 in the middle, and they're going to multiply to be a negative 20. So you could see that. You could also see a difference of squares that's a little more complicated. As long as you notice that it's a difference of squares, it works the same way. For these, you can factor out a common factor. You could factor out a 4. Or you can factor it right now. So it really doesn't matter. We're going to start with factoring out 4. Always looking for that greatest common factor. Oh, that's not going to work, is it? That's a 1. Sorry about that. So pretend that's a 1x squared. I can't erase it. But I still ended up with a difference of squares here. Even though they're backwards, that's okay. I'm still going to take the square root of my first term, and then the square root of my second term. One gets a plus, one gets a minus. So this is a case where I can't switch this around because I want it to multiply to be what I started with. So this is fine. There's also a case, I just want to mention, this is a trinomial, but it's a quartic instead of a quadratic. As long as, oh, I actually wrote this wrong, I'm sorry. Sorry, go back and change that to an x squared if you wrote this down. As long as your power of your leading term is even and it's half of the power of your second term, this works the exact same way as our regular trinomials. The only difference is that our first term, instead of being just an x, it will be an x squared. Or if this was an x to the sixth and an x to the third, then this would be an x to the third. So it really ends up being whatever that one is. And we notice from this that if I did multiply this back through, I get my x to the fourth. This is also going to guarantee that my middle term is that x squared. I'm still thinking of numbers that multiply to be 6 and add to be 5. So positive 2 and a positive 3 there. So works the same way as an x squared, as long as this power is even and this power is half of that power. Okay, so this is where I want to camp for a second. Factoring when a is not 1. This is also called factoring by grouping. At least the method that I'm going to show you is factoring by grouping. We do have some that are just set up for factoring by grouping, but we're going to make the factoring by grouping happen on this. So we're noticing that our a term, or that coefficient that is in front of x squared, is not 1. And in this case, I'm always going to start by multiplying my first and my last term, writing it off to the side. Now I'm going to be thinking of two numbers that multiply to be negative 12, so not the negative 2, but negative 12, and add to be 1. Sorry. Would you go outside? Choose, please. Alright, we'll probably hear him barking in a second. So multiplying to be a negative 12, adding to be a positive 1. If we need to roll through several, we can, but I think 3, let's see, negative 3 and 4. Those multiply to be negative 12, add to be a positive 1. We're going to take those two numbers and we're going to use it to split the middle term. So I'll leave my x squared, or 6x squared the same, I'll leave my negative 2 the same, but instead of having a plus x, I'll have a plus 4x minus 3x. It doesn't matter which order these went in, I just had wrote the plus first, so I went ahead and did 4x first and then minus 3x. Once we have split the middle term, now this is where the factoring by grouping comes in, where we're going to factor out Jack. Choose, please. I'm trying to record. Where we're factoring out what the first two terms have in common, we'll factor out what the second two terms have in common. So our first two terms, we have a 2 and an x in common. We got 3x plus 2. And then we always want the other two terms, whatever we factor out, we want what's in parentheses to be the same. So I'll factor out a negative 1. I'm left with a 3x plus 2. Okay. So then my two terms come from the part that's on the outside. So one of my factors will be 2x minus 1. My other factor comes from what is repeated. So always has to be repeated. If you don't end up with it repeated, something has gone wrong, so you need to back up. So this is our factoring by grouping. Okay, so to recap, we multiplied our first and our last, got that negative 12, thought of two numbers that multiply to be negative 12 and add to be a positive 1. Once we had those two numbers, we split the middle term, and then we factored by grouping with the first two terms and the last two terms. What we factored out became the first factor, what was repeated became the second factor. If your numbers are small enough, you can sometimes just use trial and error, like we know that these two first numbers are going to have to multiply to be 6 and the last two have to multiply to be a negative 1. However, if your numbers are large enough, it's going to take you a really long time. So we want to have some sort of method to fall back on. We're going to do a few more examples just like that. So example 7, let's do this one together too. We're going to multiply that first and last, get a positive 6. I'm looking for two numbers that multiply to be 6 and add to be 7. So 1 and 6. Using that 1 and 6 to split the middle term. And I didn't say that up here, but we're just writing that 7x is the same as x plus 6. Same here, that positive x is the same as 4x minus 3x. So nothing has changed from here to here as far as the value of it. Factoring by grouping, I can factor an x out of the first two terms. I can factor a 3 out of the second two terms. What I've factored out becomes the first factor. What's repeated becomes the second factor. Okay. I want you to go ahead and pause the video right here and try one on your own. So go ahead and pause and try example 8. Try to get through the whole thing on your own, and then I'll go through it as well. But pause, try it. Multiplying 3 and 8, getting 24. My two numbers that multiply to be 24 and add to be 10 are 6 and 4. Factoring by grouping, taking a 3x out of the first two, and if you switch these, that'll be a little different. That's okay. It doesn't have to look exactly like mine, but some of yours will look like mine. Factoring a 4 out of the second two terms. I get that x plus 2 on both. My first factor being a 3x plus 4. Second factor should be an x plus 2. So just a few more examples. We have the type of factoring where factoring by grouping is all you can do. It's actually set up to do that. These are the type that you're given 4 terms, and typically it is a cubic already. So instead of having a quadratic, it is a cubic. And we're looking at it and saying, okay, it has 4 terms, so I don't have a whole lot of other ways that I can factor it. So I'm always going to try factoring by grouping. And then if that doesn't work, it probably means that it's not factorable, or it's some special type of factoring that it's not going to make a whole lot of difference whether we memorize. So for this one, looking at those first two terms, still same as our quadratics, that I can factor out an x squared. For the second two, I can factor out a 3. And if I get to this point and once I've factored out both of those and what's in parentheses is not the same, and I double check my work and I've done it correctly, but it's just not the same, it just means that it's not factorable by grouping, and that's okay. It may just be not factorable at all. Still going to take what I factored out to make my first factor and what's repeated to make my second. There we go. Okay. Same thing. Go ahead and try this one. Pause it. Try this one on your own. Oh, can't factor out a 2. Let's see, what can we do? Just a y squared? Mm-hmm. 9. 2y minus 3. Okay, so this one works as well. We'll have a y squared plus 9 and 2y minus 3. And when we're factoring something, typically we're wanting to factor it completely, or we're using it to solve. So once I have those two factors, I do always want to check to see if I could go any further. So for these, I can't factor either of those further. I can't factor either of these further either, but this one is close. So if this was a y squared minus 9, now I would have a difference of squares, and I could keep going. So I wanted to do just a few examples. You're going to have a couple of these on Delta Math where you're combining the methods. So maybe you start with one method, but then you can continue using another method. So our first example of combining the methods, this one's a little strange, but it's still a difference of squares. I only have 2 terms. Both of them are perfect squares, even though we're not super used to saying that x to the 12th. But I can still take the square root of x to the 12th, and I get an x to the 6th. My square root of 81 is 9. I get a plus and a minus. And here's where I want to pause and see if I can keep going with one of these, and this ends up being another difference of squares. So I'll leave the first factor, but the second factor I can go ahead and take the square root of my first term, the square root of my second term, and then one gets a plus, one gets a minus. So now we're done. And I know that we're done at this point because neither of these are a difference of squares, they're only 2 terms. With this one, I have an x to the third, so that's not a perfect square, and neither is 3, so I don't want to go any further than that. Okay. And then our last one, first noticing that I've got this 3 at the front. If I can factor 3 out of everything, I want to do that. Sure can't, so I'm not going to start there. But it is negative, so maybe I want to fix that, factoring out a negative from everything. I also have an x to the third, x squared, and x, so I can go ahead and factor out a negative x. Don't get rid of it, just factor it out. That's going to be something I'm a little more used to. I didn't change my sign there. It should be negative. A negative 14x and a positive 16. So our next step, we're multiplying that 3 and 16. We get 48. Looking for our two numbers that oh, that might not be right. Is that 48? Oh, yeah, it is. Second guess myself there. I guess I could have done that in my head. Just anyway, forget me. Multiply to be 48 and add to be a negative 14. So since our numbers are a little bit bigger here, you may have to go through your factors of 48. So 1 and 48, 2 and 24. That's not going to get us there. 3 and 16. Which I know we just multiplied those, that's why we have 3 and 16, but if that did add to be a negative 14, then we could use that. 4 and 12, 5, no, 6, 8, oh yeah, they could both be negative. Okay, so we get to our 6 and 8. So sometimes it does take a little while. I probably should have looked at these beforehand, but trying to look at them truly while you guys are. Sometimes it takes a little while to go through your factors or even use a calculator to look at factors until you arrive there, but it looks like a negative 6 and a negative 8 will work. That multiply to be 48, add to be a negative 14. So I'm splitting that middle term. Make sure your negative x stays out there, still hanging out. I'm factoring by grouping, factoring what I can out of the first two terms, so it looks like a 3x. Factoring what I can out of the second two, and keeping in mind I want it to look like this, so instead of factoring out an 8, I'm going to factor out a negative 8. We do end up with that, oh, end up being the opposite. Well, shoot, what did I do? I changed my sign here and here. Maybe I wrote the problem down wrong. We had both of those were negative. Took out a 3x. Oh, I'm sorry. When I took out that negative, you guys are probably like yelling at me. When I took out that negative 8, that should be an x minus 2. But that's where having that in parentheses where it has to be the same really does help you, because if it doesn't end up being the same, we got to back up and see what has happened, or if we've taken out the wrong thing, which I did take out the right thing. I just didn't consider the sign when I divided by negative 8 there. So then our last step, what's outside of the parentheses is one factor. What is repeated inside the parentheses is the other factor. Whew! And now we're done. Alright, so some of these can be a little bit tricky. Hang with it. Look back at your different methods. Definitely factor out your greatest common factor first, and then go from there. But you can do it.